Hi, today our group will present electric and magnetic principle in aircraft system. So my name is Wan Musharif bin Wan Muhammad Nasir. My group members Nadine Gwen, Yuli Ting and Darshan Alalaki Chandran.
Firstly, I would like to introduce about the electrical principle in aircraft. Electrical systems are critical components in modern aircraft operation. They power important components like electric motors, generators, electromagnets, and transformers. This system helps to manage important functions like propulsion control, navigation, instrumentation, and safety mechanisms. Overall, electrical systems are key to operational efficiency, system reliability, and both the safety of aircraft and its passengers. There are several principles in an electrical system. Firstly is electromagnetism, which is the core of aircraft electrical system. So what is electromagnetism? It is when electricity and magnetism are interlinked. This happens when a current flows through a wire. It creates a magnetic field. This interaction allows the conversion between electrical and mechanical energy, which forms the foundation for motors and generators. This principle uses Faraday's law of electromagnetic induction that explains how a changing magnetic field induces current in a conductor. Next is DC motors. It uses a magnetic field and a rotating armature with commutator to create mechanical rotation from electrical energy. The commutator reverses the direction of current at precise interval, which helps to maintain its continuous motion. These motors allow for precise speed control and quick response time, which is ideal for application requiring adjustable motion. Next, we have AC motors, which operates using the principle of alternating current and electromagnetic induction. It is widely used due to their efficiency, robustness, and its low maintenance. There are two types, which is synchronous motors and induction motors, which is known as asynchronous motors as well. So for the first one, synchronous motors, the rotors run at the same speed as the rotating magnetic field, while for asynchronous motors, the rotor receives power by induction with no physical electrical connection. Then we have generators, which works as converting motion back to electricity. So generators work in reverse by converting mechanical rotation, such as turbine, into electrical energy via electromagnetic induction, which is Faraday's law. There are two types of generators, which is AC and DC. For AC, it is common in aircraft because it produces three-phase power for onboard system, while DC generators are used in auxiliary systems or older aircraft. Lastly, we have transformer, which is a voltage control device. It uses electromagnetic induction for step-up or step-down voltage levels in AC circuits. It is important for matching voltage requirements of various systems and for safe distribution of electric power throughout the aircraft.
Hi, now I will explain about application in aircraft system. Okay, first of all, I will explain about electromagnetism in aircraft. So there is a few places that use electromagnetism in aircraft. For example, landing gear locking system, door actuator, automatic switching system, and emergency system RAT. Okay, so the purpose of electromagnetism in aircraft is for remote, safe, and quick activation of electrical circuits, improving automation, safety, and acting as an emergency power source. So the picture show the emergency system RAT, which is used in case of main power source is failed to generate energy. Okay. For DC motor in aircraft, it used in servo system, actuator, wiper system, and control surface. So the advantage of this motor is it have accurate speed control, compact, and low cost. So it's relevant because it enables fine control of flight surface and system. So the picture show the example of aircraft DC motor that used in aircraft. Okay, for the next application, I will talk about AC motor in aircraft. So AC motor is used in fuel pump, gyroscope drive, and air conditioning system. So the purpose of AC motor in aircraft is to synchronous motors maintain constant speed, critical in timing and rotational application like engine RPM indication. Also, the induction motor are rough and safe starting, especially three-phase, making them suitable for continuous operation. Okay, so the picture show the example of the AC motor that applied in aircraft system. Okay, so for generator in aircraft system is it used in aircraft engine alternator and auxiliary power units APU. Yes. So the purpose of the generator is to provide onboard electrical power, including backup systems. Okay, so the picture below show that how the generator work and how it's built. Okay, so for the last application, the transformer. It used in voltage regulation within aircraft electrical distribution system, and its purpose is to ensure proper voltage level for various avionics and passenger systems. Okay, so there is three types of transformer that used in aircraft system. For example, pulse transformer, toroidal power transformer, and switch mode transformer. The picture shows the example of application of generator AC/DC motor in aircraft system. Okay, as you can see, there is auxiliary power unit generator that located at the back of aircraft, and there is also integrated drive generator located at the turbine of the aircraft, and there is also a DC power distribution assembly at the back, middle, and at the front of the aircraft. So this picture show the flow of the electric in aircraft.
Hi, very good day. My name is Darshan, and I will be doing the conclusion part. So to conclude, we have covered how fundamental electrical and magnetic principles are not just theoretical concepts, but are essential to the safety, performance, and efficiency of modern aircraft. Each component listed here, whether it's electromagnetism, indoor actuators, or DC and AC motors in flight control system, plays a critical role in making aviation more precise and reliable. For example, electromagnetism allows quick and remote activation of safety mechanisms like landing gear locks. DC motors help with controlled responsive motion in actuators and wipers, while AC motors maintain systems that must run consistently, such as fuel pumps and gyroscopes. Generators are the aircraft's powerhouse, supplying energy to all these systems and providing backup during power loss. And transformers ensure that the electrical energy distributed throughout the aircraft is at the correct voltage level. This is crucial for both system compatibility and safety. So by understanding these core principles, not just what they are, but how and where they are applied, we gain insight into how aircraft maintain their complex functionality, even in high-stakes environments. Ultimately, a solid grasp of this principle empowers engineers and aviation professionals to innovate, troubleshoot, and maintain systems that are vital to both flight safety and performance. Before we wrap up, it's important to highlight why this electrical and magnetic principle matters so much in aviation. First, aircraft systems today rely heavily on electrical reliability. From navigation and flight control to safety systems, any electrical failure can have serious consequences. Failure in components like motors, generators, or transformers don't just mean inconvenience, they can directly jeopardize flight control and passenger safety. And as we move toward more electric aircraft, understanding this system isn't optional, it's essential for both maintenance and design engineers. This shift also brings advantage, which is electrical systems promote greater efficiency, enable automation, and help reduce the mechanical complexity of traditional aviation system. So, having a strong grasp of this principle doesn't just help us understand current technology, it also prepares us for the future of aviation.